Hi everyone, my name is Sinaga. I am from the Department of Chemistry, Medan State University.
Hi everyone, my name is Mardia Sani and I'm from the Department of Chemistry at Medan State University.
Hi everyone, my name is Envi. I'm from the Department of Chemistry at Medan State University.
Hi everyone, my name is Joyce Sinaga. I'm from the Department of Chemistry, Medan State University.
Every day, industries and millions of vehicles rely heavily on fossil fuels to power modern life. However, this dependence comes at a cost: air pollution, increasing greenhouse gas emissions, and rising concern over fuel availability and energy prices. These challenges highlight the urgent need for cleaner and more sustainable energy solutions. Meanwhile, Indonesia is rich in natural resources, including coconut oil. Unfortunately, non-edible coconut oil and its byproducts remain largely underutilized, despite their high triglyceride content and great potential as renewable feedstocks for biodiesel production. In addition, conventional biodiesel production still faces several challenges, including low reaction efficiency, less effective catalyst performance, and complex product separation processes. This limitation reduces production efficiency and hinder the wider application of biodiesel.
To address the energy and environmental challenge, here we introduce green biodiesel innovation, an innovative approach that converts underutilized candle nut oil into a renewable biodiesel using a potassium hydroxide activated zeolite catalyst. At the core of this innovation is a KOH activated zeolite catalyst. The activated zeolite serves as a reusable heterogeneous catalyst, while the potassium hydroxide enhances the catalyst active site, accelerating the trans-esterification reaction and improving biodiesel production efficiency.
Beyond producing biodiesel, this innovation delivers several important advantages. It utilized underused coconut oil as a renewable feedstock, employs a reusable KOH-activated zeolite catalyst to improve production efficiency and support the transition toward cleaner and more sustainable energy. Ultimately, it contributes to reducing dependence on fossil fuels while promoting environmental sustainability.
This research was conducted on May 21, 2026 at the Chemistry Laboratory, Medan State University, to investigate the effect of different methanol percentage on biodiesel production from candle nut oil using a potassium hydroxide activated zeolite catalyst. The biodiesel was analyzed for yield, volume, and density. The materials used were candle nut oil, methanol, potassium hydroxide activated zeolite catalyst, and distilled water. And then for apparatus are beaker glass, volumetric flask, zero root element flask, watch glass, measuring cylinder, porcelain crucible, magnetic stirrer, hot plate, and separatory funnel. For the research procedure, the first is preparation of 2 molar potassium hydroxide solution by dissolving 11.2 gram of potassium hydroxide in distilled water and diluting it to 100 ml in a volumetric flask. The solution was mixed and cooled to room temperature. The second is zeolite activation. 10 grams of zeolite was soaked in 100 ml of 2 molar potassium hydroxide for 12 to 24 hours, then heated at 100 to 120 degrees Celsius for 1 to 2 hours. The third is trans-esterification, which mix the candle nut oil with 1.1 gram of activated zeolite catalyst and methanol at 30, 40, 50, 60, and 70%. The mixture was heated at 60 to 65 degrees Celsius while stirring for 1 hour. Then settle for 6 to 12 hours until 2 layers form.
analysis of characterization result. Different methanol percentage affect biodiesel production from candle nut oil using KOH activated zeolite catalyst. Increasing methanol from 30% to 50% improve biodiesel mass, volume, and yield, with highest yield of 95.47% at 50%. Further, increases from 60% to 70% reduce both mass and yield. Biodiesel density range from 0.837 to 0.9 gram per mil, indicating that methanol percentage also influence its physical properties. Overall, methanol concentration significantly affect both the quantity and the quality of biodiesel.
The first graph shows the effect of methanol percentage on biodiesel density. The density decreased slightly from 0.842 gram per milliliter at 30% methanol to 0.837 gram per milliliter at 40%, then increased to 0.85 gram per milliliter at 50%, and 0.86 gram per milliliter at 60%, and then 0.9 gram per milliliter at 70%. Only biodiesel produced with 50% and 60% methanol met the Indonesian national standard. According to collision theory, increasing the methanol percentage increased effective molecular collision, while the potassium hydroxide activated zeolite catalyst lowers the activation energy, making the reaction more efficient. Therefore, 50% methanol was the optimum condition because it produced the highest biodiesel yield with a density that met the SNE standard.
The effect of methanol percentages on biodiesel yield. The biodiesel yield increased with increasing methanol percentages and reached its maximal value of 95.47% at 50% methanol. According to collision theory, increasing methanol percentages increases the frequency of effective collisions between methanol molecules and triglycerides, while the KOH activated zeolite catalyst lowers the activation energy, making the reaction more efficient. However, at 60% and 70%, the yield decreased, indicating that the reaction had already reached its optimum condition. Therefore, 50% methanol was considered the optimum percentage because it produced the highest yield while maintaining biodiesel quality that met the SNI standard.
Increasing methanol percentage from 30% to 50% raised biodiesel volume from 30 ml to 38 ml. Higher methanol concentration and KOH activated zeolite catalyst boost effective collision and trans-esterification efficiency. 50% methanol gives the maximum yield of 38 ml, the optimum condition. Further, addition to 60% and 70% reduce volume to 35 ml and 32 ml. As excess methanol no longer improve reaction. This 50% is the optimal percentage. Our innovation demonstrates that waste can become a valuable source of renewable energy through science and innovation. By optimizing biodiesel production with a potassium hydroxide activated zeolite catalyst, we hope this research can inspire further development in sustainable fuel technology and contribute to reducing dependence on fossil fuels. Together, let's transform waste into a cleaner and greener future. Thank you.